Hey everybody, today we will look at the application questions on energy. I'll focus primarily on three questions that I find quite interesting and worth to take note. Okay, for the first question is a partial question. We will look at question 7 at the worksheet that I given to you, okay, which is 7.2, okay, question 7. Okay, in this question here we are looking at a person throwing a ball up, and the path of the ball in the air is actually given in the question. Okay, the various path is A, B, C and D. Okay, the thing that I want to focus for this question is not on it is not on that the part AI, part 1 and part 2 is actually difficult. It's actually on the concept behind this particular situation. For example, if you do a energy analysis for the path of the motion, you'll find at point A, okay, when the ball left the hand of the man, okay, you'll find that the energy possessed at this instance is actually only EK. Okay, that's the most obvious one. But EK, kinetic energy, is not the only energy, because at this particular point in time, the ball is actually a certain height above the ground. Okay, so this is actually certain height, okay, like I call it HA, okay, vertical height above the ground. And this, because of the vertical height, the ball at position A actually possesses, okay, what we call potential energy. Okay, so it means at position A, ball A actually possesses two types of energy, okay, which is EK at A and actually EP at A. So we have these two energy that we are looking out for. Okay, I repeat, EP, potential energy at A, is because of the height above the ground. So indirectly we are saying that the ground, okay, and the ground is actually your ground level, which is height equal to 0 meter. So this is what we mean by your ground level. Okay, the lowest part in the question we always assume it to be the ground level, which is h equal to 0 meter. And for point B, okay, you'll find that for point B, the height is at a certain distance above the ground. Okay, so which means if it's an ideal situation, which let's do an ideal one, which is that no air resistance. Okay, no air resistance. Okay, so at point B, what we are looking out for at point B is the same thing. I have actually EK, okay, of a certain amount, and actually I also have EP at a certain amount. Okay, in this case, EP is due to the height at these instances, which is, I will give it as HB. Okay, so for point A and point B, you'll find that the energy available is actually kinetic energy at point A and point B. So if you look at it in terms of conservation of energy, energy at point A or energy at point B, okay, would be actually derived from the energy at point A, okay, whereby what we call the conservation of energy is taking place now. So whatever energy I have at point A is actually converted to point B, okay, in just that it's in various forms. For example, at point A, I have a certain amount of kinetic energy plus a certain amount of potential energy. Okay, at B, okay, I will also have kinetic energy. Okay, I will also have kinetic energy. I also have potential energy. Okay, the total or the sum of energy, the total energy at each stage at B and the total energy at A is actually the same. Okay, this is what we mean by conservation of energy. The total amount and the total amount here is actually the same. So what is the difference between these two sections is the quantity. For example, at A, because my height of A is much smaller than the height at B, this will indirectly means that the potential energy at B is actually much higher than A, because the vertical height is larger. So which means the correct quantity that we are looking at in terms of magnitude is that the EP here would actually be much more than the EP here. Okay, so look at the proportion, the size. In terms of sizing, okay, I would like to represent that if potential energy at B is more than potential energy at A, okay, I will do it by in terms of dimension, okay, the size of the letter, okay. So as for kinetic energy, okay, what happens is when the ball left the hand at point A, it possesses certain amount of energy, okay. So which means the kinetic energy at point A will be actually the highest, okay, will actually be the highest as compared, and when it go up, as it get higher and higher, the velocity of the ball, the speed of the ball actually decreases. So thus, the kinetic energy at B, is actually smaller. So what we have here is that when the kinetic energy at A is actually slowly converting to potential energy. So whatever kinetic energy I lost at A is actually converted to potential energy at B. Okay, so as such, when we look at the conservation of energy, the energy is actually conserved at all the stages. It's just that the amount for each type of energy changes, okay, over the stage, over the time. Okay, so as a result, you have this particular section here. Okay, you have this particular conservation of energy equations. And likewise, if you look at point C is what we call the highest point. Okay, the highest point in the path. Okay, highest point here, you actually have some important factors that students need to be careful. Okay, highest point here also imply, okay, two things. First, the height here will be the maximum. Okay, and at its highest point, when the ball go up to the highest point, the ball will actually stop for a while, because the velocity is slower and slower and slower. So at the maximum instant, the ball will actually stop for a split second before he makes his way down again due to gravity. So which means at point C, at the highest point, the speed of the ball at this point is actually the lowest, or what we call 0. So there will be a point where it's instantaneously at rest. Then after that, he will make his way downwards, increasing his velocity due to gravity. So which means at point C, at these instances, you'll find that number 1 will tell us, since the H is the maximum, EP will actually be maximum. And from point 2, whereby the velocity is highest, you'll find that it gives us the second information whereby EK is actually 0. So if you look at the conservation of energy, at point A, I have both EK and EP at certain proportions. At point B, EK and EP are at certain proportions, and eventually at point C, all my kinetic energy at point A will actually be converted to potential energy. Okay, so this is what we talk about conservation of energy. The energy possessed by the body actually changes. Okay, but one thing for sure is that the total energy at A, the total energy at B, and the total energy at C will always remain the same. Okay, because of conservation of energy. Okay, so that's why for this particular case, okay, students will have to pay particular attention at each stage. Okay, depending on which stage the question is asking, the energy structures, the energy components, the constitutions will actually changes. So to find the exact amount at each stages, students really need to apply conservation of energy and the respective mathematics formula to look up and to work out the unknown. Okay, such as this. Okay, so usually if I have point A and point B, I will have the conservation of energy in this case to be this way. So if I am looking at point A and point C, for example, energy at A will be equal to energy at C. So if I'm looking at point A and point C, you'll find that point A actually possesses EK, possesses EP. But whereas all this energy will be converted to a single energy at point C, which is potential energy only. Okay, so if you look at the equation in terms of the composite of the equations, okay, it's slightly different. But one thing for sure is that, okay, the total energy for each of the stages actually remains the same. Okay, so for this, I hope it will be clearer for students to see how the energy conservations, energy changes, okay, throughout the stages, especially for flight, when the object is in flight, in motion. When I throw up certain things, the student need to be careful. For example, in flight, highest point, it will always dictate by the maximum height. velocity will be 0, there will be a split instantaneous, and conservation of energy at each stages is actually the same. The only difference is the components of energy we are referring to is actually different. Okay, so students, please take note of this particular checkpoint or these instances. Okay, with this is what this is the end for this particular question 7a. Okay, in the meantime, okay, if you have not done your quick check 7.2, okay, please finish up the question and look at, and if you have done it, okay, you can continue to proceed on to quick check 7.3, okay, to see what are the possible gaps that you are facing. Okay, the next video I will be looking at will be 7.3, quick check 7.3, question 2. Okay, so we'll see you then. Okay, thank you.